In this video, we're going to take a look at section 6.4 on simplifying radical expressions. The first type of problem will have us adding and subtracting radical expressions. To do this, we will combine like terms, much like we would with polynomials, by adding or subtracting the coefficients. However, we have to expand our definition of what like terms are. Like terms are terms that have the same variable part and the same radical part. So as long as they have both the same variables and the same radicals, meaning it's the same root with the same number inside the radical, then it qualifies as like terms, and we can combine them together by adding or subtracting the coefficients. All right, so for example, we have 7 square root of 7 plus 9 square root of 7. So this one doesn't have any variables, but we have a radical here, square root of 7 in the first term, and we have a radical in the second term. It's also square root of 7. So these are like terms because they have the same radical parts. Because they're like terms, we can combine these together. We'll do that the same way we would combine 7x plus 9x. It's the same idea. We're going to add, or in this case, or I should say, add or subtract. In this case, it's going to be add. Add these coefficients together. So 7 plus 9 is going to give me 16. And then the radical part stays the same. Square root of 7 just gets copied over. So we have 7 square roots of 7. To that, we are adding 9 square roots of 7. So altogether, we have 16 square roots of 7. And like I said, it works very much as if we had 7x plus 9x, which we would know to be 16x. Right, so same idea. For the example here on the bottom, we have 4 cube root of 7 minus square root of 6 plus 2 cube root of 7 plus the square root of 6. So these are not all 4 like terms, but we have a couple of pairs of like terms. So these two terms that both have a square root of 7, those would be like terms. We combine those together by adding the coefficients in front of them. So 4 plus 2 is going to give me 6. The radical part stays the same, so we'll have cube root of 7. And then this negative square root of 6 combines with this positive square root of 6. They just happen to cancel each other out this time because we have negative 1 here, positive 1 here. That gives me 0. And so those cancel out, and so my final answer here would just be 6 cube root of 7. All right, let's take a look at another example. Here we have 9 square root of 180 plus 5 square root of 45. These, starting out, are not like terms, right? These are not the same radical, so they don't have the same radical part, meaning they can't be added together, they can't be combined. However, we can simplify these square roots by what we learned in 6.3, splitting this number up, applying the square root to each number separately, and getting something out of that square root. We can't simplify the whole thing, but we can at least extract something out of it. Now 180 is a little bit difficult to simplify because you might, if you don't look far enough, you might pick something like 4, right? 4 is not a bad number to write here. 4 times, I don't even know what it's going to be, 45 looks like is what we would get there, right? And that will simplify, right? If we apply the square root to the 4 and the 45 separately, the square root of 4 simplifies to 2, but that isn't adequate enough because 45 could be simplified again, right? And the way we'd simplify that is 9 and 5. So if you want to get it simplified all at once and get the biggest number out that you possibly can, you want to split this up as 36 and 5. All right, so you could do it like that. It just takes a little bit longer to get through. So what I erased wasn't wrong. It just takes a little bit more time. If you want to get it done all at once, you want to rewrite 180. You want to get the biggest number possible that you can take the square root of. So just because 4 works doesn't mean you want to settle on 4. Explore further. Is there any other numbers that I could split out of this that I could simplify when I take the square root? And if you dig deep enough, eventually you would come across 36 as a number that you can extract out of 180. 36 times 5 is what gives me 180. I apply the square root to each of those separately. The square root of 36 is 6. The square root of 5 copies down. Now we do have a 9 in front of this square root, which also needs to get copied down. And it's going to get multiplied to what we just found when we simplified square root of 180. And because these are being multiplied, we can actually multiply these numbers together, right? So 9 times 6 is going to give me 54 square root of 5. We'll do the same thing with the second term. This one's a little bit easier to handle. Square root of 45, we just talked about that. We can write that as 9 times 5. We apply the square root to each number separately. The square root of 9 becomes 3. The square root of 5 copies down. We'll also copy down the 5 that was in front of this square root to begin with. Then when it multiplies to the result that we just got here, 5 times 3 is going to give me 15, and the square root of 5 copies down. And we're adding these two things together. So after we simplify, these two things which were not like terms to begin with become like terms. They both have a square root of 5, so we can add these together by adding the coefficients. 54 plus 15 is going to give me 69, and then the square root part stays the same, square root of 5. All right, let's take a look at another example. Same idea here. These do not start off as like terms, but we have an obligation to simplify these before we move on to the next problem. And what always happens with these problems is after you simplify, they become like terms. And so this time it's a cube root. Keep that in mind. So we're going to split this up a little differently because it's a cube root. What we want to get with a cube root is either 8, 27, 64, or 125. And so from 24, I can split this up as 8 times 3. We apply the cube root to each of these separately. The cube root of 8 becomes 2. The cube root of 3 doesn't simplify. We just copy that down. And then this 3 that we started off with in front of this radical also copies down, still getting multiplied to the result that we just got. And 3 times 2 is going to give me 6. So we get 6 cube root of 3 plus whatever we get from this. This will split up as 27 times 3. Right? So again, with a cube root, 81 is not very helpful, right? Square root of 81, that would have been perfect. We would get 9. Cube root of 81 doesn't simplify directly. So what we do want to get out of a cube root is either 8, 27, 64, or 125. Those are my targets, right? And so with 81, you can try 8 first. 8 doesn't work. It doesn't divide into 81. And I wouldn't bother with any other numbers. I'd just go right to 27. And if 27 didn't work, I would try 64. Right? So those are the target numbers when you're dealing with a cube root. So you focus on those. Right? And it turns out 27 does work. Right? So we apply the cube root to the 27 and the 3 separately. The cube root of 27 is 3. The cube root of 3, we just copy that down. And this one didn't have a coefficient in front of it. It's a 1, right? I mean, I guess technically it does. It's a 1, which means this will still be a 3 here, right? So there's no number to copy down in front of this. So that's why I copied it all the way down to this bottom line. And as I mentioned at the beginning of the problem, they become like terms after you simplify. That happens on this problem every single time, pretty much. There could be an exception to that, but most of the time, after you simplify, you get like terms. So now we'll combine these together. We have 6 plus 3, which gives me 9 cube roots of 3. And that's my answer there. Okay. The next type of problem will be multiplying these rational expressions. And to multiply, again, it's very much like polynomials. Just like we were doing adding, subtracting, we're like polynomials. You combine like terms. To multiply, it's like polynomials. You either distribute or you FOIL. And then after you do that, you simplify and combine like terms where possible. All right, so let's take a look at a couple of examples. So here, we have square root of 7 times the square root of 10 minus the square root of 11. So what we're going to do is we're going to distribute this time. And we will get square root of 7 times the square root of 10. And then the square root of 7 gets multiplied to the square root of 11. And we'll subtract those two things because that's what we have here in the parentheses. All right. So we multiply these. We learned about this in 6.3, the previous section, that these can be multiplied together into a single radical. right? So square root of 7 times square root of 10 is going to be the square root of 7 times 10. Same thing will happen here. The square root of 7 times the square root of 11 is going to be the square root of 7 times 11. We multiply them into a single square root, and then we can simplify, right? 7 times 10 will be 70, minus 7 times 11 will be 77. And then we could try to simplify these and go from there, but these don't simplify, right? So there's no way to split up 70 to simplify this square root. You know, you could, again, you can write it as 7 times 10, you could write it as 5 times 14. None of those numbers will simplify with the square root. And the same thing happens with 77. There's no way to split that up where anything gets simplified, so we just leave it the way it is. And again, these are not like terms. This does not become negative square root of 7 or something like that. I see students who do that on the test, right? If the radicals are not the same, they're not like terms, you just have to leave them separate. All right, let's take a look at this example. Again, we will distribute. So we'll have 7 cube root of z times 6 cube root of z squared, and then minus 7 cube root of z times 4 cube root of z. All right. Now for these, again, we kind of practiced this situation in, I think we did, maybe in 6.3. I don't know. Now I'm thinking back to it. And I recorded that video a few days ago, so I can't remember all the details of the problems that we looked at. Maybe we didn't see a case like this. So I'm just going to assume we didn't and just explain it from scratch. So whenever you're multiplying two radical expressions together like this, you multiply together what goes together. And what I mean by that is you multiply the numbers outside the radicals together because they go together. 7 times 6 will be 42. That's why I said 4, because the answer is 42. And then you multiply the radicals together as long as they are the same root, right? So this is a cube root, this is a cube root. We can multiply those together into a single cube root. And so I'll get the cube root, just kind of like how we did up here. I'm just going to jump right to the conclusion. We'll have z times z squared, which gives me z to the third power. So I'm going to multiply these together into a single radical. Minus, we'll do the same thing here. We have 7 times 4, which is 28. Those go together. And then we'll have the cube root of z times z, which is z squared. So you multiply together what goes together. And the reason we can do that is because these are all being multiplied together, so we can rearrange, right? This is 7 times the cube root of z times 4 times the cube root of z. It's all multiplication in that term, so those things can be rearranged and multiplied in any order that we want. So we are choosing to multiply the 7 with the 4 first, and those go together to give me 28. And then I'm choosing to put the cube roots last. And when those multiply together, we get cube root of z squared. And then we can try to simplify, and this time we actually do have something that simplifies. This cube root cancels out this power of 3. Right? Cube roots cancel out powers of 3, and so we end up getting 42z minus 28 cube root of z squared. So this one does not simplify. There's not enough powers here to cancel out with the cube root, so we just have to keep that the way it is. But this one does simplify to just being z. And again, these two things are not like terms, so we cannot combine these together. So we just have to leave them separate, and this would be my final answer. All right. This case is the case where we FOIL. We have 2 terms times 2 terms. So we will use the FOIL method, which is first, outer, inner, last. We multiply the first 2 terms together. We'll get square root of 11 times the square root of 11. Let's go ahead and write that out. We'll multiply the outer terms together. Now, I'm going to start paying it. I didn't really point this out in the last couple of examples because I think we kind of worked around it okay. But this is positive, this is negative. So you might want to take that into account starting now. So this will be positive times a negative, which will be negative. And then we'll have square root of 11 times 4 square root of 10. It's not that we were ignoring this in the previous examples. I just didn't mention it in the way that I'm mentioning it now. But that's what was happening here, right? This is positive times a positive, so this term was positive. This was positive times a negative, so we have a minus sign here. We had a negative sign. So I just kind of worked around it by putting the square root of 7 after the minus sign. It worked out fine. But here, for FOIL, that just doesn't feel like it works for me. So I'm pointing it out this way. It's positive times a negative, which will be negative. For the inner terms, it's positive times a positive, which will be positive. And we'll have 4 square root of 10 times the square root of 11. And then for the last two terms, we'll have positive times a negative, which is negative, 4 square root of 10 times 4 square root of 10. All right. So that's foiling it out, that's multiplying it, but we can't leave our answer as a giant mess like this. So we need to simplify these things. So these two numbers, square root of 11 times the square root of 11, multiply together into a single square root. It'll be the square root of 121. Here, again, we multiply together what goes together. The 4 has nothing to multiply to. There's no other number in this term for it to multiply to. So we'll just copy the 4 down. But the square roots can be multiplied together. Square root of 11 times the square root of 10 is the square root of 110. All right, plus, the same thing happens here. The 4 has nothing to multiply to, so we just copy it down. And when I say you're multiplying together what goes together, that is not the same as combining like terms. That's a whole different topic. Combining like terms occurs when you're adding and subtracting. In that case, the radicals have to be the same in order for you to add or subtract the terms together. But for multiplication, that's not a requirement. So you just multiply together what goes together. The numbers outside the radical go together. The numbers inside the radical go together. And that's what we're doing here. So square root of 10 times the square root of 11 for multiplication. The radicals don't have to be the same. You just multiply them together as they are. 10 times 11 is going to give me 110 again. Right. Minus, again here, we'll multiply the numbers outside the radicals together. 4 times 4 will give me 16. And then we'll multiply the numbers inside the radicals together. Square root of 10 times the square root of 10, multiply together to give me square root of 100. All right, then you simplify further. There's a couple more things we can do, surprisingly. Square root, having trouble talking tonight, square root of 121 is 11. It's one of the ones we're supposed to have memorized. These are like terms, and not only are they like terms because they have the same radical part, they actually just cancel each other out. We have negative 4 plus 4, that's going to be 0. So these two just cancel each other out. And then here we're going to have minus 16 times the square root of 100, which is 10. It's another one we're supposed to have memorized. And so these are being multiplied together. This is 16 times the square root of 100. So that becomes 16 times 10. And then order of operation, we multiply first, so that'll be 160. And we'll have 11 minus 160, which will be negative 149. So that's ultimately the answer that we get there. All right. Let's take a look at well, before we look at another example, there is something I want to point out. There's a major shortcut that we could have used here and that I would like to use in future problems. So I want to point it out to you now. And this shortcut only works with square roots. It doesn't work with cube roots, doesn't work with fourth roots. When you multiply a square root to itself, we did the work here, we went through all the details of it, but ultimately, when you multiply square root of 11 times the square root of 11, the answer was just 11. And the same thing happened here, right? Square root of 10 times the square root of 10, when those got multiplied together, ultimately, the answer was just 10. So that is a definite shortcut. It's completely true that when you multiply a square root to itself, you just get whatever's inside of that square root. The square root goes away and you get whatever number or variable is inside of that square root. But this only works for square roots. So keep that in mind. That's a really handy shortcut that will come up quite a bit for these problems. And maybe we'll get to use it here in one of these examples. All right. So this one, same thing, we're going to FOIL. So first, multiplying the first terms together, we get 8 times 2, which is 16. The outer terms, again, positive times a positive will be positive. We'll get 8 times the square root of 3, which we'll just write as we spoke it, right? 8 square root of 3. This one's negative times a positive, which will be negative. We'll have square root of 3 times 2. We'll talk about how to format that in just a second. And then for the last terms, we have negative times a positive, which is negative. And then let's use our shortcut this time. square root of 3 times the square root of 3 ultimately just equals 3. Again, you could write that as square root of 3 times the square root of 3 is the square root of 3 times 3, which is the square root of 9, which simplifies to 3, right? That's all the detail behind it that leads to that result. But with square roots, this is always true. Square root of 3 times the square root of 3 ultimately is just going to equal 3. So let's take advantage of that here, save ourselves a couple of steps. This should be written with the number in front of the radical. That's typically how you write it. If you have a number outside the radical, you write it in front of the radical where possible. So I could have done that here without writing it like this, but I just wanted to take our time with it, go ahead and write it the way it comes out from the FOIL process. But normally I wouldn't bother writing it this way. I would have just written it like this, 2 square root of 3. So I just put that number in front of the radical instead of behind it. And then I combine like terms, right? So 16 minus 3, those are like terms. Combine those together, you get 13, right? 16 minus 3 is 13. And the middle terms here are like terms. We have 8 square root of 3 minus 2 square root of 3. So they have the same radical, which means they're like terms. 8 minus 2 is going to give me 6, positive 6. And then the square root of 3 just gets copied down, right? The square root part doesn't change. The radical part doesn't change when you're combining like terms. Be especially careful when you're getting answers like this. I find students that do pretty well in other circumstances make a mistake here because it looks like you should be able to take 13 plus 6 and add that together to get 19. But these are not like terms. They do not combine together. You have 13, which has no radical at all, and then 6 square root of 3, which does have a radical, meaning these are not like terms, which means you cannot combine them together, which means they have to stay separate. That would be my final answer. If you had 13 square root of 3 plus 6 square root of 3, that's when you could add these together to get 19 square root of 3. But in this case, they don't combine together. All right. Let's take a look at another example. All right, so a lot more going on here. So let's use our shortcut that we talked about the last couple of examples without having to write it out in detail. All right. See if that'll save us some time. So we'll multiply the first two terms together. Positive times a positive will be positive. And let's just try to mentally, work this out without having to write out all the details. So we're going to multiply together what goes together when these get multiplied together. The 2 and the 5 outside the radical will multiply together to give me 10. And then the square root of 5 times the square root of 5 will multiply together using our shortcut to give me 5, right? When you multiply a square root to itself, you just get whatever number is inside that square root. So I'm just going to get 10 times 5 here, which is going to be 50, right? That's for multiplying the first two terms together. Then we're going to multiply the outer terms. Positive times a positive will be positive. Again, we'll get 2 square root of 5 times 15 square root of 2. So we will multiply the numbers outside the radical together. 2 times 15 will give me 30. And then we're going to multiply the radicals together. Square root of 5 times the square root of 2. Those are not the same, so there's no shortcut here. We just have to multiply those square roots together, but they multiply together into a single radical. 5 times 2 gives me 10 inside of this single square root. We'll multiply the inner terms together. We have negative times a positive, which will be negative. We'll have 6 times 5, again the numbers outside the radical multiply together to give me 30. And then square root of 2 times the square root of 5 multiply together to give me square root of 10. And then we'll multiply the last terms together. Negative times a positive, again, will be negative. 6 times 15, multiply the numbers outside the radical together, we get 90 from that. And then square root of 2 times the square root of 2, when we multiply the radicals together, since they're the same, the square root just goes away and we get whatever number is inside the square root, which will just be a 2. And again, that'll multiply together to give me negative 180. All right, so now we can combine like terms. We have 50. So 5 times 10 again was 50. 50 minus 180 is going to give me negative 130. And then we have the middle terms, which are like terms, which again, coincidentally in this case, happen to just cancel out, right? We have positive 30 here, negative 30 here. They have the same radical, so they're like terms, We combine them together, the 30s cancel out, we just get 0, so it just goes away. Right? That's just gonna 0 out. And so we get negative 130 as our final answer. All right, so that concludes the video on section 6.4 on simplifying radical expressions.